Okay, we are on page 16 today, and we're going to talk about graphing quadratic functions from our last form. We're going to look at graphing when we have a standard form today. So that Delta Math assignment, you have many, if not all, of the problems where it asks you to graph a quadratic function, give you the function in standard form. Last time we talked about how to graph from factored form, and we did just one problem about changing from standard form to factored form. So that's an option. If you want, you can take your standard form function and change it to factored form and graph using our strategies from last time. But I also want to talk about other approaches that we have for graphing from standard form. So remember, standard form for a quadratic tells us the y-intercept for that function. Intercept, there we go. Standard form looks like y equals ax squared plus bx plus c. A is the same A that we talked about for the last two function forms, for vertex and factored form. That tells us the shape of our graph. So do I open up or down? Am I stretched or compressed? What's going on with the shape of my graph? And then the key feature that we get is the y-intercept, and that comes from C. So C is our y-intercept. Now, having the y-intercept is nice, and depending on what we're trying to do, that's a useful piece of information. However, if what we're trying to do is get an accurate graph of our function with a lot of correct points plotted, which is generally our goal, then standard form might not be our best option. We can get a really nice graph with just one point and the shape of our graph, with just one point in that A value. If the point I have is vertex form, and that was the first graphing that we reviewed, was graphing from vertex form. So I plot the vertex and I use what I know about the shape to decide where the next couple of points go. But if my y-intercept is not the vertex, then it can be kind of difficult to get more accurate points on that graph. I know which way it should open, but without the vertex, that can be kind of difficult if I just have the y-intercept. So if I'm going to graph a function from standard form, we're going to change it to vertex form. So this is called graphing from standard form, but what we're really going to do is take standard form and rewrite it as vertex form. So what we're going to do, again, is change to vertex form. Remember, this process is called completing the square. Okay? The vocab is what most of us, if we had an issue back in Unit 8 or Unit 9 or in our 4 function forms review, the vocab is what most of us struggled with. So you guys know how to change from standard form into vertex form. It was just that completing the square line in the directions that we stumbled on a little bit. Okay, just remember, do you see completing the square? That's what we're going to do right here. So if I want to change this to vertex form, remember vertex form looks like x in parentheses with some number squared. And the number that I put in parentheses here is my b value cut in half. So -6 cut in half is -3. Be careful with your signs. And then we keep the c that we have, but then there's an adjustment that we need to make. So remember, when I rewrite this as x minus 3 squared, that means I've got x minus 3 times x minus 3. If I distribute that back, I get x squared, which is good. I had x squared. I want to make sure I still have it in some form. And then I get minus 3x and another minus 3x. When I combine these, I get the minus 6x that I had, which again is good. I want to make sure I have all the pieces that I had originally. But here's the kicker, and you guys have seen me do this a few times. -3 times -3 gives us this extra +9 that I didn't have before, and that I don't really want now. So to adjust for that extra 9 that we're adding in, our last bit of completing the square is to take whatever our cut in half number is and subtract that cut in half number squared. So just like we added an extra 9 here, when we rewrote this as x minus 3 squared, we have to subtract that 9 away. Okay. And then our last step to have this in vertex form is just to tidy it up. So I would get y equals x minus 3 squared, and then combine our like terms here. 6 minus 9 would be -3. Now I've rewritten this in vertex form, So I'm going to treat it the same way we did when we were graphing from vertex form. I'm going to start by identifying my vertex, which is 3, -3. And I'm going to plot that 1, 2, 3, 1, 2, 3. And now I need to know the shape of my graph. So I can get that from the A value in standard form or from vertex form. It's the same value, right? I don't see anything in front there, so that means that it's 1. So from my vertex, I'm going to go out 1 and up 1 on both sides, and then out 2, up 1, 2, 3, 4. Out 2, up 1, 2, 3, 4. I also know, because I had standard form to start with, the y-intercept for this function. So I've got the vertex and I use that to graph. What was the y-intercept for this thing? 6, yeah, that guy right there, 6. So if I wanted, I could also plot the y-intercept. 1, 2, 3, 4, 5, 6. And then connect our points. So we have our sketch of our parabola. Questions for me so far? Okay. For B, let's start with our y-intercept. What's our y-intercept? -2. Remember, it's that value with no x, that constant term. And now since I want to graph this, I'm going to change it to vertex form. So this would be x with something squared. The something is our b value cut in half. So 4 cut in half would be 2. We keep the c that we have, so -2 at the end. And then we have to subtract our cut in half number squared. So 2 squared is 4. When I tidy this up, I get y equals x plus 2 squared. And then when we combine our like terms here at the end, -2 minus 4 would be -6. So my vertex here is -2, -6. I can plot that point now. 1, 2, 1, 2, 3, 4, 5, 6. And then again, I look at my A value, my lead coefficient, either from standard form or from vertex form. It's 1 either way. And that tells me we're going to open up and be the same shape as our parent graph. So out 1, up 1 on either side. And then out 2, up 1, 2, 3, 4. Out 2, up 1, 2, 3, 4. And don't forget to connect your points so you can see the shape of your parabola. Questions for me on B? Is this familiar? Yeah, it should be. We've done this several times at this point. Okay, the last thing I want to talk about with standard form is how to change it to factored form. Again, we talked about how to graph from factored form by plotting those x-intercepts. I know my vertex should be halfway between them, and then it's just determining how far up or down to go based on that lead coefficient. So if I wanted to, I could also change my standard form to factored form and graph that way. Yesterday we took a look at, or last time I should say, we took a look at factoring when I had no GCF and my lead coefficient was just 1, so I just had to find factors of C that added to B. Today we're going to look at a couple other examples just as a quick refresher. So if I look at 2a, do I have a GCF, a greatest common factor here? 2. I could divide all of these terms by 2, so I'm going to go ahead and do that. So I get x squared plus 6x plus 9 with my GCF of 2 out in front. Now for what I have left in parentheses, my lead coefficient is just 1, right? I don't see anything exciting in front of x squared there. So at this point, I'm just looking for factors of C that add to B. So numbers that would multiply to get me 9, but add to get me 6. What do I want? Multiply to get me 9, but add to get me 6. 3 times 3. So my factored form here would be y equals 2 times x plus 3 times x plus 3. How about B? Do I have a GCF here? No, I can't divide all of these numbers by the same thing. I don't have a value I can factor out of each of those. Since my lead coefficient, my A value, is not 1, I can see a number in front of x. That means that we need to use a C method. So I'm going to take my A and my C values and multiply them together Be careful with your sign. Okay, this is -6, so I need to make sure that sign stays in there. 2 times -6 gives me -12. Now I want factors of -12 that add to +1. 4 times 3, one of them's got to be negative, what do you say? -3, good. 4 times -3. Now remember, for AC method, okay, I can't just go straight to my factored form from here, okay? I'm replacing the middle. So we keep that first term, that 2x squared, that stays exactly the same. We're replacing the middle, so plus 4x minus 3x, and then my last term stays the same as well. So I still have that -6 there. Now that I've rewritten this in 4 terms, we're gonna use grouping. So first 2 things and last 2 things, and then we're looking for the GCF for each group. What's the GCF for my first group? 2x, very good. So I'm going to factor that out of my first group. That would give me x plus 2. How about my second group? What's the GCF there? -3, good. Remember, anytime your group starts with a negative, we're going to pull out a negative. So -3, and that would leave me with x plus 2. Again, be careful with your signs. This also works if you have swapped the 4x and the -3x. So if my first class of the day, we had 2x squared minus 3x plus 4x minus 6. We're going to get the same factors that my first Algebra 1 section got, okay? Now at this point, my stuff in parentheses should be the same. If it's not, you need to go back and double check your work. Make sure that you were careful with your signs, right? Here we had a negative number, so I needed 1 positive and 1 negative. Make sure I was careful when I rewrote that I kept the first term and the last term the same. Make sure I pulled out the entire GCF, the greatest common factor, not just a common factor, but the biggest one I could find, and make sure you divided it out of both pieces. I've seen pretty frequently where we divide our GCF out of that first term, but not the second. So make sure you check all those things. Since our stuff in parentheses is the same, I can go ahead and pull that out like a new GCF. And then my other factor is the stuff that's left over. So 2x minus 3. And that's my factored form. Question for me for today? Okay, that's it. Just a couple of practice problems for today. Again, because our graphing from standard form was really graph from vertex form again, and we've already done quite a few examples on that. So I didn't want to spend a ton of time doing work that we just did a couple of days ago.